What's up, everybody? This is Coach Sharf. Welcome back to my Algebra 2 notes videos. And today we are continuing our notes in Unit 4 on radical equations. My contact's bugging me a little bit, so if y'all see me blinking a lot, or I'm trying to adjust my eye, I'm sorry. My contact's bugging me a little bit. But we're continuing Unit 4. So today we're going to focus on solving radical equations. So let's just go ahead and jump into that. So we're solving radical equations. This is actually concept 2. There's kind of 3 main concepts with Unit 4. The first was it kind of combined the converting from radicals to rational exponents and the properties of rational exponents. So that was the first video. And now on this one, we're focusing on solving radical equations. So a radical equation is when I have a equation that has a radical, which is, again, just, trying to draw it and see if it's going to look right. Square root sign, there we go. It's flipped from the camera, so I was doing it backwards. Radical is the square root sign. So equations with radicals that have variables in their radicands. Again, the radicand is the part that's under the radical. So it's a radical with a variable underneath the radical. It's called a radical equation. An example is 2 times the square root of x plus 1 equals 4. This 2 is out in front. This is 2 times. The 2 is not a little 2. It's not a little 2 in there like it's index. Try to make a tiny 2. So it's not an index, it's just a regular 2. So to solve a radical equation, follow these steps. Isolate the radical on one side of the equation if necessary. We got to get the square root or the cube root, because we're going to be dealing with cube roots as well, by itself. So in the case of the example we have, I would have to get the square root of x plus 1 by itself, so I'd have to get rid of the 2 out in front. After we do that, we can raise each side of the equation to the same exponent to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. So raise each side of the equation to the same exponent. So, okay, I got to put an exponent on both sides of the equation. Well, how do I know which exponent? Whatever one eliminates the radical. I said it, I think, in pretty much all the classes at one point or another, most of them recently, but at one point or another this year. I think order of operations should be PEMDAS, not PEMDAS. So you got parentheses are always going to come first. ER is exponents. We know E is exponents, but R is roots. Exponents and roots go together. They're opposite functions. So when I got to raise it to the same exponent to eliminate the radical, whatever roots I have. So in this case, this is a square root. I'll kind of isolate it by itself. This is a square root. So you don't necessarily, if it's by itself, you don't necessarily have to put it in parentheses. You can choose to do so if you want. I would raise it to the second power. Again, if you choose to do parentheses, that's fine. But the square and the square root are going to cancel out and leave me x plus 1. And whatever is on the other side, I would square as well. So it says we're going to obtain a linear, quadratic, or other polynomial equation. Most of them are going to be linear. If I actually work this one out, 4 divided by 2 is 2. So then I would square it and get 4. So I'd actually have this, x plus 1 equals 4. This is a linear equation, the equation of a line. If you really wanted to make it the equation of a line, you could just subtract 3 from both sides and have x minus 3. That would be your slope-intercept form. Mx plus b, slope of 1, y-intercept to -3. So that would be linear. We have a few problems where we're going to see a quadratic, which got a couple examples we're going to talk about, or other polynomial. That's kind of getting into if I had a cubic function, but we're not going to go that deep into it. Step 3, solve the resulting equation. So x plus 1 equals 4. Subtract 1 on both sides, x would have been 3. that you learned in previous chapters. Check your solution. There may be extraneous solutions. So again, that word extraneous, root word is extra. An extraneous solution is a solution that even though we got it from doing correct math, when we go to plug it back in for X, something doesn't work out. So the two most common ones, I'm going to kind of keep the example short because I gotta run through these a little more quickly than I want to. But the two examples where I have extraneous solutions, I might get a situation where I'm trying to take a negative square root. So let's say the square root of -9. We learned at the beginning of the year that we would get 3i from this, actually plus or minus 3i, the imaginary number. But we're not dealing with imaginary numbers right now. So I can't take the square root of that. So this would mean whatever X value, let's say I plugged in, if it was the square root of X minus 12, I said X was 3, 3 minus 12 is -9. So I can't do this. So that means 3 is extraneous in that case. Again, we're not really going to see a lot of extraneous. We're not really going to worry about it right now. You also might run into it occasionally, very, very occasionally. Again, probably not one we're going to see, where if you work out all the math, you plug in X, work out all the math on both sides, you get like 6 = 4. That is your final answer, which of course is not correct as well. All right. So with all that being said, let's just jump into some examples. So starting off very, very easy. Got 4 square roots. Square root of X = 5. Square root of X = -5. Might need to move put my giant head down here at the bottom. Kind of moving around. Y'all aren't used to seeing it down here. Square root of X = -5. Square root of X minus 7 = 0. Square root of X plus 7 = 0. First thing I gotta do, isolate the radical. Get the radical by itself. In this case, it's just the square root of X. There's nothing else on the left side of the equal sign. So it is by itself. Same situation here. On this one, the -7 is still underneath the square root. So all of that is the square root. Again, nothing else on the left-hand side. So on all of these situations, the square root is already by itself. So next step, raise each side to the exponent to eliminate the radical. Since this is a square root, I'm going to raise it to the second power. Again, you can optionally put it in parentheses if you wish. That's going to cancel out and leave me X. But I have to do it to both sides. So I also have to do 5 squared, which is 25. X = 25, easy peasy. The next problem, square root of X = -5. Square both sides again, that cancels out here. Remember, now when I'm raising any negative number to an exponent, if you're putting in your calculator, you need to put in parentheses. Can't do -5 squared in your head, -5 times -5. You can put it in your calculator, but make sure you use parentheses. Otherwise, you're going to get an incorrect answer. So I got -5 squared, -5 times -5, which is also actually positive 25. So tying everything back together, going all the way back to the August 4th or August 5th, 3rd or 4th day of school, depending if you were in even and odd class. I don't have it pulled up, so I'm not going to waste time pulling it up, but the general vocab PowerPoint, first thing we did, very first term was plus or minus. The example was the square root of 25 is equal to plus or minus 5. So that's how it ties back in. So 25 is the correct answer for both of these, even though I got +5 for one, -5 for the other, because it can be either or. It's going to be a little different down here now. So I had +5, -5 here. Now I've got -7, +7. Because it's not solely because it's on the left-hand side, but because it's on the left-hand side, but more importantly, because it's underneath the square root. Now the negative sign comes into play more, where I'm not squaring it and turning it back positive. So I am actually going to get 2 different answers for this. Square root of X minus 7 = 0. Again, this is by itself, so I'll put this one in parentheses, square both sides, cancels out, leaves me x minus 7. 0 squared, what's 0 squared? 0. 0 times itself, how many ever times is 0? So x minus 7 equals 0. Add 7 on both sides, x equals 7. Next one, x plus 7 equals 0. Again, nothing else here. So I square it to cancel it out, leaves me x plus 7. Square 0. Still get 0. Now I minus 7 on both sides. X equals negative 7. So there's my 4 answers. Here's my 4 answers. All right. So the next slide, let me move my head now. Next slide. Oh, don't know what happened there. There we go. Next slide. X to the 1/2 power equals 5, x minus 7 to the 1/2 power equals 0. The 1/2 exponent is the same as taking the square root. We talked about it. I will pull this up real quick. We talked about it on the last set of notes that we saw in the last video. 1/2 exponent is the same as the square root. 1/3 exponent is the same as the cube root. So there we go. Nope, no more step. There we go. All right. So same as square root. So squaring it will cancel it out. Treat it the same way as we would a square root. So x to the 1/2 power, I got to make sure it's by itself. Again, there's nothing else on the left-hand side of the equation other than x to the 1/2 power. So I'm going to square both sides. 2 and the 1/2 cancel out. Again, going back to the last set of notes, this actually ties into the power of a power exponent property. Now we do x. Again, you don't have to write this down. You don't have to prove this to me. I'm showing y'all where we get it. So x to the 1/2 times 2 power. 1/2 times 2 is 1. So x to the first, which is x. So when I say this cancels out, it doesn't technically cancel out, but it multiplies to give me 1. X to the first is the same thing as x. So we can essentially treat it like it cancels out. X equals 5 squared is still 25. Over here, same thing. Square this whole side, it cancels out. 0 squared is 0. X minus 7 equals 0. Add 7 on both sides. X equals 7. If the 1/2 exponent confuses you, I'm going to go ahead and put this out there right now. If the 1/2 exponent confuses you, you still got to realize 1/2 exponent is the same thing as taking a square root. If you don't have that locked down, you're not going to have a shot at getting this right anyway. You got to know the 1/2 exponent is the square root, but even if you know that in your head, but you're still looking at this 1/2. I know this is the same thing as a square root, but I'm still not sure what to do with this 1/2. I forget what to do with this 1/2, even though it's the same thing as a square root. I don't remember how I get rid of it. Well, if this is the 1/2, if the 1/2 is the same as the square root, turn it into the square root of x. X to the 1/2, square root of x are the same thing. So turn it into that. Now you could say, all right, 2 cancels out. X equals 25. So if you need to change the 1/2 exponent, or later on when we see cube roots, the 1/3 exponent to the square root or the cube root, you can do that. Y'all can pause these, by the way. Like I said, I'm moving a little quick though. So if you need to pause to finish writing, of course, you can do that. If you need to go back to anything, you can do that as well. All right, so now we're going to add an extra step. I don't think I'm making it any more difficult. We're just adding an extra step. Square root of x minus 3 plus 4 equals 7. Got to get this by itself, square root of x minus 3. But now I have this plus 4. So it's still algebra, okay? It's still algebra. I'm gonna subtract 4 on both sides. I don't know why I changed colors. I should have kept green. Doesn't matter. 4, -4 cancel out. 7 minus 4 is 3. Still have the square root of x minus 3. Now my square root is by itself. So now I will square both sides. Square and square root cancel out. X minus 3 equals 9. Add 3 on both sides. X equals 12. So there's that one, nice and easy. Again, nothing's stopping you from going back and checking this if you want to. I know, I haven't really been so far, and I know it said you're supposed to check for your solutions. Like I said, pretty much everything we're doing is going to be correct. You don't have to worry about extraneous solutions. I'll just show it with this one real quick though, just in case you want to see it. I got 12. I need to plug it back in here. Square root of 12 minus 3 plus 4 equals 7. Anything underneath the square root is essentially in parentheses. So I do 12 minus 3, which is the square root of 9, plus 4 equals 7. As I said, roots tie in with exponents. So when I have a root, I have to calculate that before I do anything else. Square root of 9 is 3. 3 plus 4. Again, I only want the positive, not the negative, obviously. Square root of 9 is positive 3. 3 plus 4 is 7, which of course checks out. All right. Next problem. X minus 6 to the 1/2 power minus 1 equals 4. Similar problem, but instead of the square root, I have the 1/2 exponent. Got to get this by itself. So I got to get rid of -1. I add 1 to both sides. X minus 6 to the 1/2 power equals 5. Again, 1/2 is the same as the square root, so I would square both sides to cancel it. X minus 6 is equal to 25. Add 6 to both sides. X equals 31. So there's that. Again, if you need to change this, I'll show it real quick. X minus 6 to the 1/2 power minus 1 equals 4. Go ahead and change it. You don't have to get rid of the 1 and get it by itself before you change it. Go ahead and change it first. So that's still going to be a square root of x minus 6. Minus 1 is still outside, equals 4. All the other steps are the same. This point plus 1. Square root of x minus 6 equals 5. Square both sides. X minus 6 equals 25. Add 6 to both sides. X equals 31. So there's that. All right, so hope you got the last 2 problems down. This one and the slide before. I had these 2 problems for y'all to do. I'll move my head again so we can see this one. These 2 problems for y'all to try on your own. I had y'all try them on your own in class. Had your classmates go up to the board and answer. I want y'all to try them on your own. Okay. I want y'all to try them on your own. So I'm gonna stop talking for about 10 seconds, which will be time for you to pause the video, leave these up on your screen and work them out. After those 10 seconds, again, you'll have it paused. You don't have to pause it for just 10 seconds. Pause to work them out. Unpause the video. I'll wait a few more seconds to make sure everybody had time. I'm not going to work them out, but I'm just going to tell you what you should have gotten for X. Okay. If you worked everything out right, what you should have gotten is your answer. So I'm going to pause about 10 seconds right now, and then I'll show the answers. Pause the video so you can work them out. All right, hope you got a chance to work them out. For number 1, you should have gotten X equals 28. For number 2, you should have gotten X equals 7. If you did not get those, try to look back at them on your own and see if you can figure out what your mistake was. If you're unsure, you can ask me about it in class or send me a message and remind. In particular, if you're quizzing tomorrow, I'm recording this on Tuesday. So if you're quizzing on Wednesday and you're watching this tonight on Tuesday night, send me a remind message. I do have a baseball game tonight. This only applies in real time. If I happen to share this video next year, it may not be the case. Might not have the game the same night that before we quiz on this, but if you're in February 2022, February 15th, 2022, today to be exact, tomorrow's the 16th. If you're looking at this tonight, send me a message and remind. I'll get back to you whenever the game gets done. Probably about 8:30 or so, maybe 9 o'clock once we get on the buses. All right, so there's those problems. A couple more examples with square roots. I'm aiming for 145. It's about to be 137 right now. I might have to go a little over. 2 times the square root of x plus 4 equals 6. This looks pretty similar to the snip from the book. It was 2 times the square root of x plus 1 equals 4. Again, this 2 is multiplying. It's out in front. This is not an index of 2. This is multiplying. So to get the square root by itself, I divide both sides by 2. And I was supposed to go through here, not the square root. I saw the square root. Square root of x plus 4 equals 3. Square both sides. X plus 4 equals 9. Minus 4 on both sides. X equals 5. So there's that one. I think there's actually one. It's not X plus 4. There is one on the worksheet when you get to the worksheet that kind of combines the last two. It has the number in front and a number after. So let's say, for example, it was this. It's 2 times the square root of x minus 4 plus 4 minus 9 equals 6. I would have to add 9 first to both sides. Let me actually make this 8, so it'll be an even number. Add 8 to both sides, divide by 2, square both sides, and then subtract 4. That's number 10 on the worksheet, I believe. Kind of similar to that. I think it's might be 3x underneath instead of x plus 4, if I'm thinking about it right. This problem is like number 6 on the worksheet. So I'm starting to make references to the worksheet, so maybe I'll need to go pull those out. I just remember 2 problems I have to do that I forgot about. Yeah, this is going to take longer than 145. Square root of 2x minus 4 equals the square root of x plus 5. Square roots on both sides. I still do the same thing. Got to make sure this is by itself on the left. It is. Got to make sure this is by itself on the right. It is. So what happens is I square this. It cancels out. Leaves me 2x minus 4. I square this side. The square root cancels out over here as well. X plus 5. I've got a 2-step equation. That's all I got. Really a multi-step equation. 3 steps technically. Add 4 to both sides. 2x equals x plus 9. Subtract x on both sides. Well, actually, no, technically it is 2 steps because I just get x equals 9. 1x, 2x minus x is 1x equals 9, which of course is just x equals 9. If you happen to have a number here, like if this was 4 minus 1 is 3x, you would still have to divide by 3. I think that's how number 6 is on the worksheet. You do that, you still end with, no, it's 5x minus 4x actually, never mind. But if you had to do that, that's what you would do. But minus x on both sides, x equals 9. All right, so honestly, what I might do is just do this problem and the next one and save cube roots, maybe do a shorter video on cube roots. I don't know, because I'm running out of time. I'll see what I can do. If I got to run a little over, I got to run a little over. Actually, let me text Miss Belk right now, so I don't even have to go across the hall. But look at what we got right now. So there's not dead air while I'm typing. I have the square root of x minus 1 equals x minus 3. The square root of x minus 1 equals x minus 3. Radical is by itself. Nothing else on the left-hand side. So I square that, cancels out. Leaves me x minus 1. So now I got to do a square somewhere on the other side. Again, if we go back and look at the original notes page, each side of the equation, I got to raise each side of the equation to the same power. So when I'm doing it here, I'm not just sticking the 2 on x. I'm not just sticking it on 3. Not even sticking on both is technically not correct. This is kind of where putting it, the idea of putting in parentheses comes back in. So let me actually kind of back out. The idea of putting in parentheses comes back in. I put this whole side in parentheses and square it. I can't talk. That's still going to cancel out, leave me x minus 1. When I put this whole side in parentheses and square it, got x minus 3 quantity squared. Think about what it means to square something. Move my head up now. I think I could do that. When I'm squaring something, it means I got to do x minus 3 times itself. X minus 3 times x minus 3. Multiplying 2 binomials together. So we know we got to do the distributive property and multiply everything. The 2 methods are the FOIL method, of course, and the box method, which is what I prefer. Again, it's like the Punnett squares y'all did in biology. So x minus 3, multiply the boxes out. X times x is x squared. 3 times x, negative 3x. Negative 3 times x, negative 3x. Negative 3 times negative 3, positive 9. X squared, negative 3, and negative 3 is negative 6. Positive 9 goes there. So now I got x minus 1 equals x squared. I lean back a little bit, sorry. X squared, or x minus 1 equals x squared minus 6x plus 9. This is where it was saying, when it said linear, quadratic, or other polynomial, now we have a quadratic. We have a quadratic over here. But really what we got to do is, this x squared is what's kind of probably messing y'all up. If it was just 6x, 9x, and 1, most of y'all could probably do it. This x squared is probably what throwing y'all. Y'all probably haven't had to do some algebra with this a lot. When I have this x squared, it's going to stay. There's nothing to get rid of it. So what I got to do is, I want to keep positive x squared. I'm going to move everything to the same side and have 0 on the other side. So I'm moving x and negative 1 over here. So I got to do that by canceling them out. Minus x, add 1, gives me 0. Minus x, add 1, gives me x squared minus 7x plus 10. So still have a quadratic. Got to see about factoring that quadratic. What can I multiply to get 10? That adds up to get, or subtracts, adds or subtracts to give me 7. It'd be 5 and 2. 10 is net positive, so both my signs have to be the same. 7 is negative, means both are negative. Negative 5 and negative 2, add to give me negative 7. And multiply to give me positive 10. So those are my 2 factors. And my solutions, again, you can do x minus 5 equals 0. X minus 2 equals 0 if you need to do it that way. But applying that 0 product property I've talked about all year, if we can make this set of parentheses equal 0, doesn't matter what's over here. So how can I make negative 5 cancel out? I would use positive 5. How can I make negative 2 cancel out? Positive 2. So those are my 2 solutions. This is where we're talking about extraneous solutions we would need to go check, which I'll do really quickly. So square root of x minus 1 equals x minus 3. Square root of x minus 1, 5 minus 1 equals x minus 3. 5 minus 3. I plugged in 5 here. Square root 5 minus 1 is 4. So I got the square root of 4 equals 5 minus 3, which is 2. Square root of 4 equals 2. That checks off. So 5 is good. Using 2, however, square root of 2 minus 1 equals 2 minus 3. 2 minus 1 is 1. Square root of 1 equals 2 minus 3 is negative. In my book, especially with what we just talked about back here, about plus or minus 5, square root of 25 being equal to plus or minus 5, the square root of 1 can be equal to negative 1. Square root of 1 would actually be equal to positive or negative 1. So in my book, this is correct. So 2 works. I don't remember where I saw it last year, but something I was trying to use last year was saying this was invalid. Square root of positive 1 still has to be positive 1. It can't be negative 1. So in their book, this was incorrect. It was saying 2 is extraneous. It's an extra answer we don't need. If we run across that come test time, not quiz y'all are doing tomorrow and Thursday, on my quiz, it'll still be good. So both, there will be one problem like this. I'm about to do another example. Both answers you get should, if you do the math correct, should be correct. You don't even necessarily have to check them. When on test time, I got any questions I use on Illuminate, I need to make sure count both answers. If there's a question like this on Illuminate, I give you on the chapter test at the end of the chapter and the end of the year. But both answers are good in my book. Okay. All right, next problem like this. Square root of x plus 10 equals x plus 4. We're going to pick up the speed a little bit. Square both sides. X plus 10 on the left. I do x plus 4 times x plus 4. X4. Yeah, it's positive, so you don't have to put the negative sign, or the plus sign, rather, I'm sorry. X times x. X squared. 4 times x, 4x. 4 times x, 4x. 4 times 4, 16. So I've got x squared, 4x plus 4x is 8x plus 16. Subtract x and 10 from both sides. Minus x minus 10. Gives me x squared plus 7x plus 6. What can I get to multiply? It's positive, positive. So even when I go to factor, I know both my signs are already going to be positive. X plus, X plus. What can I multiply to get 6? That adds up to give me 7. Of course, that would be 6 and 1. So now zero product property. What cancels out positive 6? Negative 6. Cancels out positive 1. Negative 1. Again, if you were to go to check these and plug them in, again, I'm not going to show it all, but I'm going to do it real quick. I would get negative 6 and 10, so I would get the square root of 4. Negative 6 plus 4 is negative 2. But again, in my book, square root of 4 is positive or negative 2. So that works. So negative 6 is good. I plugged in negative 1. Negative 1 and 10 is 9. Square root of 9 equals negative 1 and 4 is 3. Square root of 9 equals 3. Of course, we know that's correct. So both answers are correct. All right. Cube roots. I'm going to go really, really quick with the cube roots. I'm treating them exactly like we would square roots, but what we got to think about is try to make sure my hands are right. All right. So if I have a square root, I got to raise it to a second exponent to cancel it out. If I have a cube root now, so I have my cube root that's in my nook of my square root. A 2 up here is not going to cancel out 3 here. So now both of these have to be 3. So I have to raise it to a cube, exponent of 3 to cancel it out. So pretty similar setup I had to start with the square roots. Cube root of x equals 3. Cube root is by itself. Cube both sides. X equals 27. Over here, cube root is by itself. Cube both sides. -3 cubed, still put it in parentheses if you got to put it in your calculator, if you're doing it in your head. So if you're putting it in a calculator, do it in parentheses. If you're doing it in your head, -3 times -3 is +9. If y'all can see me in the window, so that's 2 -3s gives me +9. Third -3, 9 times -3 is -27. So that actually would be -27. Because now if we went to plug that in cube root of -27, you can actually take a cube root of a negative number. You can't take the square root of a negative number because two of the same number are never going to multiply to give you negative. Two positive numbers will give you a positive, two negatives will give you a positive. But I can break this down and have three negatives of the same negative number that multiply together and give me a negative. So you can take the cube root of a negative number. So the square root of -20, cube root of -27 would be -3. So that is correct. Cube root of x minus 7 equals 1. So now I've still got +1 and -1 different over here. My signs are the same, but again, because of it being a cube root, that's going to change a couple things and still give me two different answers. Cube root of x minus 7, cube both sides. X minus 7 equals 1 cubed is +1. Add 7 to both sides, x equals 8. Other side, cube root of x minus 7, that cancels out. X minus 7 equals -1 cubed is again -1. -1 times -1 is +1. +1 times -1 is -1. Add 7 on both sides. X equals 6. Again, pause if you need to. I'm moving on. 1/3 exponent. Let me move my head again. 1/3 exponent. Oh, don't want to make that smaller. Make that bigger. Put my head right in the middle here. 1/3 exponent, same as a cube root. Again, we saw it on the other set of notes. We treat it just like a cube root. Again, it's the same idea as the 1/2 exponent being the same as the square root. So x minus 1 to the 1/3 power equals 5. Want to get this by itself? It is nothing else on the left-hand side. So I cube it, raise it to the 3rd power. Still cancels out with the 1/3. X minus 1 equals, again, when it's positive, you don't necessarily have to put in parentheses. 5 cubed is 125. Add 1 to both sides, I get x equals 126. So same idea, I'll just show it with this one. Again, let me move my head over here. Get that if you need it, because I'm gonna move my head out of the way. If you're starting with x minus 1 to the 1/3 power equals 5, you could change this to, use a different color, cube root of x minus 1 equals 5. Still cube both sides, that cancels. X minus 1 equals 125. Add 1 to both sides and get 126. So it's the same thing. If you need to get rid of that 1/3 exponent and change it to a cube root, you can. This one, want to get 3x minus 1 to the 1/3 power by itself. That's the bell, so I need to go ahead and finish up. Got to get rid of the -6. Add 6 to both sides. It's going to give me +2 on the right. 3x minus 1 to the 1/3 power. 1/3 power, if it draw. Raise both sides to the cube. 3x minus 1 equals 2 cubed, which is 8. Still got a two-step equation here. Add 1. 3x equals 9. Divide by 3. X equals 3. If that'll draw. X equals 3. So there's those. Next one. Again, I'm trying to get through really quick here, as quick as I can. So both of these, let me move my head out of the way. Let me not drag it down. Let me move my head out of the way. Number out in front. So 7 times the cube root. I did this to show again, you're gonna see more ortho number out in front, but 7 times the cube root, 3 indicates the cube root. So I'm multiplying by 7. So, divide both sides by 7, it cancels out here. Leaves me the cube root. 2x plus 5 equals 3. Same thing here, divide both sides by 5. Leaves me the cube root of x plus 1 equals 2. Cube both sides. 2x plus 5 equals 27. Do it over here. X plus 1 equals 2 cubed, which is 8. Minus 5 on both sides. 2x equals 22. Minus 1 on both sides here. X equals 7. So that one's done. Last step here, divide both sides by 2. X equals 11. So 11 on the left, 7 on the right. And that's it. I thought I had one more page. That's it. All right, so that's all your square roots and cube roots. Should hopefully be enough for you to get through your worksheet. If y'all got any questions, let me know on your mind. Otherwise, I will see y'all in class.